There's a peculiar phenomenon that occurs with the water within our blood vessels, called structured water. Dr. Gerald Pollack discovered exclusion zone water, or EZ for short, also known as structured water. It's a unique, gel-like form of water that forms on hydrophilic surfaces. It's this structured water that makes up the majority of the water within our bodies. I'll let Dr. Pollack himself explain.
Whenever water meets hydrophilic material, by hydrophilic I mean water-loving, it undergoes a radical transformation. That we were astonished to see this, that the water molecules are actually lining up with one another in some ordered fashion. Like a liquid crystal, if you will, it's H3O2. Particles, and later we found molecules, are progressively excluded from this zone that was sitting right next to the surface. We also call it the exclusion zone, or EZ for short. This fourth phase of water is not neutral. Typically, it's negatively charged, and the water just beyond it is positively charged.
In concert with the negatively charged glycocalyx, the contents of the blood are driven to the center of the blood vessel as a force field effectively forms around the blood vessel walls. Then, in the context of a tube, as is our blood vessels, the structured water forms a battery, and this effective structured water spontaneously pulls the fluid along the length of the vessel, void of any pumping force.
So what you see here is the microcirculation. It's a piece of muscle, and you can see a few capillaries winding their way through. And in these capillaries are the red blood cells that you can see. A typical red blood cell looks like on the upper right, it's big, but when they actually flow, they bend. The reason they bend is that the vessel is too small. So the vessel is sometimes even half the size of the red blood cells. They're going to squinch and go through. Now, it requires quite a bit of energy to do that. And the question is, does your heart really supply all the energy that's necessary for driving this event? And what we found is a surprise. We found that if we take a hollow tube made of hydrophilic material, just like a straw, and we put the straw in the water, we found constant, unending flow that goes through. So here's the experiment. Here's the tube, and you can see that the tube is put in the water. We fill it the inside just to make sure it's completely filled inside, and put it into the water. And the water contains some spheres, some particles, so we can detect any movements that occur. And you look in the microscope, and what you find looks like this: unending flow through the tube. It can go on for a full day, as long as we've looked at it. So it's free. Light is driving this flow in a tube. No extra source of energy other than light. So if you think about the human and think about the energy that's being absorbed in your water and in your cells, it's possible that we may use some of this energy to drive biological processes in a way that you had not envisioned before.
So a direct corollary to this is the idea that the heart does not actually pump our blood. It is the pulling force generated by the EZ water that moves the blood along in our circulation, not the heart. Dr. Gerald Pollack and his team were able to demonstrate this with a chick embryo.
So the result looks like this. This is time here. And so here the heart stops and the flow goes down, but it doesn't go to zero. It goes down to some steady low value. And then to test to see whether the same mechanism is working in the vessels that we saw in the laboratory, the key is to add infrared energy and see if it flows faster. And you can see the result here. We turn on the infrared, flow increases by about 3 times, and then it comes back toward the control. So it looks like radiant energy does drive blood flow.
This effect also takes place in plants. This is what allows trees to move water against immense pressures up to gravity-defying heights.
This is also appears in plants. As you can see the particles in the xylem vessel, and he pointed out that they congregate in the middle, and along the edges, where you might expect to find EZ, there are no particles.